So good afternoon again, and thank you so much for joining today's session. Our webinar is on Solareff's journey, one of our, again, esteemed clients, and their journey with RatedPower. So I'm Yasmine, and I'm part of the business development department at RatedPower. I'm a solar PV engineer and enthusiast in the solar PV industry. I'm excited to be guiding you today through the webinar as a moderator and also part of the presenters that we have today. I'll also leave it to Altair Vega, one of our presenters in today's sessions, as well as Johann. So if you want, you can introduce yourselves.
Sure. Hello, guys. My name is Altair Vega. I am a technical advisor here at RatedPower, and I've been here over for almost 2 years. And my background is as an electrical engineer, and I am passionate for renewables and a sustainable world. Johann, it's all yours.
Thanks, Altair. Yeah, so I'm Johann Van Ellewee. I'm an electronic engineer with 14 years experience in the renewable industry. I'm the ground and large scale solution engineer at Solareff.
Thank you, Johann, and thank you so much for being present today. We're very excited to be conducting this session with you. So for the audience, I'll move to today's agenda and what to expect from our session today. So we will be covering and talking about Solareff's key role as an EPC in the industry, as well as Solareff's experience prior and with RatedPower. And then we will move to a very exciting part, which is talking more about one specific project's results and, of course, best practices. And in the end, we will have a segment for the Q&A. So feel free to drop your questions in the chat box for now, and we will be answering them in this specific segment. Also, before we start, we will be recording the session, and you will be receiving the recording later on after the session is over. Okay? Perfect. So, Johann, you can take the floor in this section, and talk to us more about Solareff and its key role as an EPC in the solar PV industry.
Thanks, Yasmine. Yeah, so Solareff is a specialist South African-based renewable energy solutions company with a proven track record of installing medium to large-scale rooftop and ground-mounted engineered solar photovoltaic and battery energy storage solutions. As a leading solar EPC provider, Solareff effectively combines expertise, technology, and resources to provide seamless energy solutions to the industry that combat rising electricity costs and carbon emissions. Innovative capex-free power purchase agreement solutions are now available, allowing businesses to enjoy the benefit of a premium solar energy solution, support by a robust technical team without the financial burden of capital and maintenance expenses. This strategic approach promotes energy independence and enhances cash flow for core business operations. Through our team of highly qualified engineers and project managers, we have successfully completed over 560 projects and have over 200 megawatt peak of commissioned and current projects across Southern Africa. Our projects have included record-breaking solar PV rooftop installations, such as the 7.2 megawatt peak at Eastgate Shopping Centre, which is currently the largest registered rooftop solar PV installation in South Africa, the 6.8 megawatt peak solution at Boardwalk Equazi in Richards Bay, and a 2.9 megawatt Clearwater Mall embedded generation project, which was South Africa's first commercial rooftop solar PV installation to break the 1 megawatt peak barrier for own consumption. From our experience in rooftop solutions, we have grown into the medium to large ground mount space, where we combine PV, BESS, and diesel generation in an engineered hybrid solution to effectively meet the customer's needs. I would like to take this opportunity to thank RatedPower for extending this opportunity to me and I'm very excited to share our experience on one of our recent ground mount projects where RatedPower played a vital role in our success.
Thank you, Johann, and thank you for amazing insights into your project. What an impressive background, and for sure a great future of pipeline ahead. What I would like to add here is that you mentioned a key and a hot topic in the industry at the moment, which is storage. So I would like to know, how are you incorporating storage at the moment into your projects? How is it important for your upcoming pipeline and to the industry specifically?
Yeah, so we've seen a massive increase in requests for incorporating BESS into our solutions. You've got the option of using BESS as a standby power or for arbitrage, and the beauty of it is that even if you need BESS for standby purposes now, in the future your needs might change, and then you can reprogram that system to use it for arbitrage or peak shaving, which is also a cost-saving benefit for potential clients.
Alrighty.
Definitely.
And so in this same topic regarding the BESS system, I just wanted to take the opportunity to give some insights to the users that maybe they're not super familiar with RatedPower. But basically, let me see here. What we do have in RatedPower is both AC and DC coupled BESS, where the users can easily and quickly obtain the layout for those systems, the BOQ, SLDs, and others. And there's quite some improvements coming along with regards to the BESS system. So in the next section, we're going to be going over Solareff experience prior to using our tool. So go, Johann. I'm quite curious to know what was your experience before using RatedPower, and what challenges were you guys facing before using our tool?
Yeah, so Altair, prior to RatedPower, generating designs and drawings that are accurate and flexible to change was time-consuming and tied up valuable drawing office resources for extended periods. This setup also required a lot of backwards and forwards between the design engineers and the CAD operators, which is definitely not ideal. So we had to look at something to streamline this process going forward.
All righty. Yasmine, do you have any questions so far with regards to?
Yeah, it's actually great, Johann, that you mentioned regarding the difference between CAD operators and powering engineers. And as you mentioned, this is something that we focus on at RatedPower. We want to focus more on how our tool can help engineers in saving their time, because time is a key factor that all of companies with your size and with your goals have as an important factor to consider. So I would also like to touch base on the large-scale utility projects that you have in your upcoming pipeline. So what made you actually realize that you need a more efficient software for those specific projects or projects that are on the large side or the large-scale ground-mounted systems?
Yeah, so we found that to put forward a competitive bid, we have to be able to optimize our solutions in a very short period of time. Optimizing by hand was just taking too long, and we found it to be an ineffective utilization of resources. This ineffectiveness can be seen as the catalyst within the company that drove the decision on finding software that can alleviate this burden on our staff.
Yes, that's definitely one of the also key goals that we are happy that you realized, and that this is one of the key challenges that that is common again with companies with your background. Altair, we can move also now to the solutions, or how, Johann, you found RatedPower to be the most suitable tool for you.
Definitely. So Johann, based on the information that you've just shared regarding your experience prior to using our tool and the things that you were looking for, what made you guys choose RatedPower to help in your design workflow?
Yeah, so Solareff was looking into software that can assist with the design of larger scale ground mount projects. The main goal of this software was to free up capacity in the drawing office, as well as giving us the ability to optimize our designs. Initially, we identified 2 software packages that we proceeded to trial run, both of them concurrently. And what we found was that with RatedPower, the decision-making power sits with the design engineer rather than with the CAD operator, as the engineer will be the one that's operating the software. This frees up drawing office time and check one of our main goals. The batch optimization features enabled us to run multiple iterations of various parameters like pitch distances and tilt angles with a single press of a button. This streamlined the optimization process and enabled us to submit proposals that are cost-effective and accurate. Once we are happy with the optimization, we could download a series of documents, drawings, models in both PDF and native format. The native format was very helpful because that gave us the ability to make minor changes before submitting any proposals to clients. But not only this, RatedPower is constantly making improvements, as Altair were mentioning earlier with regards to the base, and adding new features to the software. They are very open to suggestions and what features we need. And lastly, with regards to support, there's always a RatedPower representative ready to assist if you have any questions or problems. And being able to get a quick answer to a question is very important to us, as we do not always have the luxury of time when deadlines draws near.
All right.
Yeah, and we're always very happy to work with team members and with our clients to assist with all their questions. We also like to understand more about your goals, objectives, your roadmaps, so that we try as much as possible to also align with that. And we look forward to hearing more of your questions and requirements, Johann. Great. So also, I remember one of the things you were mentioning before in our interaction until now is a optimization and identifying, for example, key differences between your projects or designs to be able to analyze which one, for example, could be the most optimized. So Johann, do you want to tell us what are the key features, for example, that you find the most interesting through your scope?
Well, yeah, I mean, I like to play around with the different parameters that you can on RatedPower to see how decisions I make impacts the yield at the end of the day, because that it all draws back into what the output of your plant would be. And you know, as I said, you can run batch simulations at the press of a button, and you can see the impact of every increment that you do on the yield of your plant, and that's fantastic. I actually love that feature.
Yes, that's pretty interesting for us to also know, and for the audience to know that. Perfect. Altair, do you want to add anything as well?
I think we can proceed to the next phase.
Perfect. So great. I'll be now moving to the segment, which is basically the talking about project specifics and the comparison. that we had with regards to the ground-mounted PV project that Johann is allowing us to share today. So I'll start with this section. Perfect. So as you can see here, we have showcasing the three stages of the project, from the preliminary, detailed, as well as the construction. So Johann, thank you so much also for sharing your story, and for sharing also how the software helped you in the specific stages of this cycle. So how did you, if you want, you can start by talking to us more about the involvement in those stages of the project. How did your layout change? Any challenges that you had in this specific project in real life? So feel free to share your story.
Awesome. Yeah. So the first picture in the slide is obviously the preliminary layout, and that layout is actually generated by RatedPower. So we use RatedPower as a preliminary design tool and optimization to get to a point where we are happy with what output has been reached, or the goals that has been reached, or the requirements of the proposal, or the requirements of the client. Once we get to a stage where we say, okay, well, we've optimized this to a point that we are happy, then we export all of those documents, drawings, models, and everything, and we make use of that to do the detailed design. But the detailed design is obviously not done in RatedPower. That's done in CAD or other packages that we have. But we utilize the documentation that's generated from RatedPower to assist with that. I mean, you can see in these slides, there's some slight variances between the preliminary layout and the actual detailed layout. And that was just due to, you know, the natural progression of the design stages of a project. You know, during the design stages, the client had some requests, some changes that we had to make. We identified a water pipe that ran in the bottom left corner of the area, so we had to move some modules around to accommodate that. We moved the inverter area, you know, small changes like that, and all of that was done during the detail design that then progressed onto the construction, and that's the construction layer that you can see the final product, what this plant looked like at the end of the project. What's also maybe just noteworthy to mention is, as I earlier made mention of, that RatedPower does do yield simulations, but one of the documents that you can download that's generated by RatedPower is the PV Colada file, which is in a sense a 3D model of your entire plant. It actually takes into account your contours of the land as well, which is fantastic. I mean, you can see exactly what inclines there is and what levels there is and all of that. I believe that RatedPower uses Google Earth to generate those contours, but if you've got a topographical survey of the available land in a CSV format, you can actually import that into RatedPower for a more accurate layout of the land. And then this PV Colada file that you download, you can import in software like PVSys and run your simulation in PVSys with an accurate 3D model of your plant.
Alrighty. Johann, just a quick question on those different iterations or images that we have. So the first one with the preliminary layout. So you mentioned that you found out about the pipe during the detailed layout, right? Okay. And so then, since you were already doing the detailed design, you just made those shifts there to accommodate that. Did you think maybe use the software to try to adapt those as well, or?
Yeah, I mean, Altair, definitely you can do that. If you've got that pipe in a KMZ file, or you know where it is, you can import that KMZ file into your layouts and then assign a no-go area around it, and the software then will obviously exclude those areas from placing in modules there.
Mm-hmm. And I also see here that you use one of our features, the no road feature, that you can actually choose the location of the power station, which coincides with exactly where you have that red container. And then that's also where your power station is in the installation, right?
Yeah, well, it's minor change. You know, we moved it slightly into the field. But yeah, I mean, it's close. It was very close at the end of the day.
Alrighty, great. I think we can maybe proceed to the data, to the values, again, using RatedPower, and then the data using during the construction. And we can start from top to bottom. So we can see here that starting with the modules, you guys have used the same quantity as designed in RatedPower, so 100%, same quantity of inverters as well. But I see here,
we had during the simulation or the preliminary design phase, we had a set kilowatt peak that had to be reached. So we had to hit that whether or not we make changes during the detailed design. So there was no changes there.
Understood. But on the structure, I do see some slight difference. So in RatedPower, you have 161 structures with one string, and then on the construction side, you have 80 structures with two string, and then one structure with the one string. So how did those changes happen, and what happened there?
Altair, yes. So during the preliminary design, you know, you've got options on when you select your structures and how many strings per structure you want. In the preliminary design, we opted to go for one string per table. But during the detailed design, we thought it just to be more efficient to use two strings per table, and obviously less tables, less structures. So that's why there's a slight discrepancy there.
Okay, and so if you have just like two strings per structure, so you just have this longer structure, does it help with the costs maybe? Does it help with the ease of installation? Can you give some insights on those two differences?
Yeah, I mean, on this specific site, the client opted to pre-drill all the holes instead of ramming. So you can imagine the time it takes to pre-drill 1,128 holes versus 2,254. So yes, there was a massive time and cost implication to that decision at the end of the day.
Understood. Okay, now that makes total sense. Okay, so now we can go to the DC cabling. So we have around 70% accuracy here. So can you give some insight on these two variables and also what originated that increase in the DC cabling side?
Altair, yeah, so RatedPower does give you a complete bill of quantity of all the materials that it calculates using the software. But the software calculates that working in a single plane in an X and Y coordinate system.
Correct.
So there is some ups and downs, you know, from each table going down into the ground and then going back up to the inverter. That's not necessarily calculated in RatedPower, and also wastage. you know, when you install cables in the field, there's, especially on DC cables, and you're running long distances, there is some wastage on cables. So that 48,000 meters that you see there was the actual amount of cable that was ordered for this project, and that includes all the wastage and all the DC cables all across the board. And that, in my opinion, that's what accounts for the discrepancy on this.
On the DC cabling side, okay.
Yeah.
And what about, so moving on to the AC cabling, so it's about 45%. So in rated power, you have 18 meters. Construction, you have about 40 meters, and you're only using one power station with 6 inverters. What could have originated those changes here?
Well, that all boils down to inverter position. So where's the inverters installed? How far is it to your ACDB or your MV station or anything like that? You know, so that's not clearly defined in rated power, and that might change on site. So any distance increases from your inverter to your tying point will increase your AC cable length.
Okay, so then you had the inverters inside a separate container next to the power station.
Yeah, in this instance, we had an inverter building. So we had a small room that we built that housed all of the inverters and the ACDB as well.
Okay. Does it make any difference, or is it in some cases better or not to have the inverters on a inverter building or a container rather than being outside in the field?
Oh, I think it's dependent on what the client requirements are. You can have them out in the field, but then you increase your AC cable length and decrease your DC cable length. So it's a trade-off at the end of the day, whether you install the inverters inside the field or outside the field. From our experience, we tend to rather run longer DC runs and keep the AC cables as short as possible. We've seen that is a substantial cost saving on projects as well. But whether to house the inverters in a room or a container, you know, that's really client dependent. We like them well ventilated at the end of the day.
Understood. Okay, so with regards to the items shown in this table, we already cleared this out. However, I do think that maybe the people in this webinar might be wondering about other parameters such as the energy bill and the LCOE and cut-in field estimates. So can you maybe share with the audience like why you didn't provide those insights to this table?
Yeah, so specifically to this project, Altair, the civil works, cut and fill and leveling and all of that was outside of our scope. It was done directly by the client, so we were not really privy to that information. We don't know what the level was. And to the LCOE, this specific plant curtails significant. So this plant is being throttled as the load goes up and down. So we can't really give an accurate LCOE to compare to what the simulation has given us. Unfortunately, that's the nature of this project. Yeah.
Okay. Another quick question on this curtailment. Have you seen our the feature in our tool that you can actually enable the curtailment and define that capacity there?
Yes, I have seen that. I haven't used it yet, Altair, but you might maybe correct me if I'm wrong, but I don't think that's a new feature. This project was designed 13, 14 months ago. I don't believe that feature was available back then.
Okay.
But even if it was, again, for this specific project, this was the size of this plant was set by the client. He was well aware that he might be curtailing, but there is a larger plan for this. You know, there's also substantial amount of base that is included in this project, not part of our scope. It was a different project wholly on its own, and any excess power being generated from the PV plant can actually charge the batteries as well, if the batteries are not fully charged.
Understood. So is there any batteries in this project, or you're planning on adding batteries in this project?
No, it's already, the two projects ran concurrently. So there's already a substantial amount of base on this site, but it wasn't part of our project.
Understood. All right. Well, thank you so much, Johann, for those insights. Yasmine, do you want to add anything?
Yeah. No, I would like to also thank Johann for the great insights and for sharing also those parameters and how your project evolved and how you use the software to take it further to different stages throughout the process. And it's I would like to also confirm on something, Johann, and to thank you for actually mentioning it, which is the different conditions of the projects and the scope, as you will be using or utilizing, for example, the software for different goals that you might be having or for different scope. So we're really happy that you are able to differentiate between that, as well as understanding like the value of the software in terms of powering and helping engineers in their optimization stage. I think we have a couple of questions that are from the audience, so we can open it already for the questions, some of the questions. Okay.
Yep.
Great. So also for the audience, feel free to drop them in case we didn't have time to cover them during the webinar. As I see also part of your inquiries is regarding the webinar link. We will be sharing this with you for everyone attending, so you can feel free to go over it again, and we will be reaching out if we didn't answer specific questions during the call. Great. So there is one interesting question that I really found interesting, and also Johann, you touched based upon it with regards to the features updates of the software. So one of them, it says that, are there any new features in RatedPower that you would have used back then when you designed this project?
Well, I think we've already touched base on it, you know, that the curtailment feature is quite handy. If you've got the load data of your site, to make sure that you size your plant correctly, and not oversize it at the end of the day.
I think in one of the calls we had, you also mentioned a feedback, and it was last year, to be able to have different azimuths if you have like 2 or more available areas. Was that also used, or?
Yeah. So this project, it was actually called Phase 1A. So and there's still a plan for Phase 1B, but the two areas, even though they are adjacent to each other, the one on the eastern side of this plant that we built now, if the modules face true north, it would have been facing directly to a residential estate, and they were quite concerned about any glint or glare affecting those residents. What would have been nice is that, because we simulated both of those projects simultaneously, and back then we didn't have that feature where we can define 2 usable areas, and each area with its own orientation. But now that feature is there. You can actually say, okay, well, this area faces north, and this area maybe 5 or 10 degrees northeast, and use different inverters and all of that. So yeah, that's a very nice feature to use, which is now available. Unfortunately, back when we did this project, it wasn't a feature that was there.
All righty. Thank you so much, Joanne.
Thank you. Thank you, Johann, as well. And thank you, Altair, for noting this. And there's another question for you, Johann, as well. I think this is something that we covered during today's session. It's about how accurate was it translating what you ran in rated power to actual construction on site. For example, the number of panels that you got on the PV design report, the same number that you fitted on the site when you constructed the solar farm.
Sorry, Yasmine, can you just repeat that question?
The question, I think it's related to the number of panels that you fitted, comparing the results of rated power with the actual construction site.
Of the piles?
On the panels. Yeah, the number of panels.
Panels, modules.
Modules, yes.
Okay. Yeah. No, I mean, so there was no discrepancy. I mean, we installed the exact number of modules that was used in the simulation. But that's just a function of, you know, the client wanted 2.4, 2.5 megawatt peak. So we had to hit that number no matter what. We had to make it fit at the end of the day.
Perfect. Yeah, I think this is something that we also showed in the on the webinar during the session. So we will be also sharing again, as we said, the recording, so you will be able to see that there. Okay, great.
Let's see if we have any more questions.
Yeah. Okay. Another question would be also related to the accuracy and based on Johann's experience about the layout, again, created using rated power and aligned with the detailed design stage for the project completed so far. Basically, again, layout comparison from rated power to the detailed design stage. If you can share with us, Johann, like any best practices, any recommendations as well for this stage?
Yeah, I mean, so normally when you start your design, you've got a piece of land. And even though rated power is a very powerful tool, it does not take away any responsibility from the engineer. The engineer still needs to use his own engineering skills and group practices to engineer the solution as best as possible. You know, so when you've got a piece of land and you say, okay, well, I want to fit 2 or 10 or 100 meg on that land, you need to have a feel of what the lay of the land is like. You know, for instance, if you've got a steep incline or a decline from north to south, and you start placing your tables, you need to think about inter-row shading, because that is going to affect your yield. And the steeper that incline is, the further away you need to place your modules. And likewise with the tilt angle. So if you increase your tilt angle, the higher your structure becomes, the larger shadow it will cast, and you will have to increase that even further. So yeah, that's why you need to run those batch simulations where you can actually see, okay, well, what is the effect of increasing tilt and keeping the pitch distance the same, because you will have a negative impact on yield. So I tend to start by looking at the tilt angle and say, okay, well, let's play around with the tilt angle, and then get to a point where you say, okay, well, now I'm comfortable, and then do some batch simulations by increasing your pitch distance and actually look at that number, your yield generated for the plant, and you see how it increases. Then it's safe to assume that, well, if it increases, you know, there's obviously some shading between the rows. And if for whatever reason your yield decreases, you realize, okay, well, hang on, my train of thought is now wrong. I'm going in the wrong direction. I need to go back to my original design and start or try something different to try and increase the yield.
Definitely. Thank you, Johann, actually, for the explanation and for answering the question. Also, again, for the rest of the questions, we will make sure to send you the answers if we weren't able to cover them during today's session. There's another question also, Johann, related, asking about the total area and total megawatt capacity of the PV plant. I believe that the one that we were talking about earlier.
Yeah, I think it depends on the technology that you're using. You know, so this specific plant was fixed tilt. It was in a 2P configuration and with a tilt angle of 15 degrees. And it was a 2.5 megawatt plant, and we roughly used 2.5, 2.8 hectares of land. That being said, as soon as you go single axis tracker, you need substantially more land for the same amount.
Alrighty. Yasmine, I do also see here another insightful question. Johann, so someone is asking here if you ever use the topography feature for applying limits and earthwork. He wants to know if for this construction, if there was much work to do on the structures that were accepted in the design, but would need to do some earthworks on them. So they're asking about the earthworks, if you use them in those estimates.
Are you using about the topographical constraints?
Yes, the feature that we have in RatedPower. Did you ever use them, and did you use for this project?
I have used them on different projects, not specifically to this one. On this one, it was relatively flat. There was no real issues there, so it wasn't really necessary. But we have used it on other projects where you might have a steep slope in a east-westerly direction or a north-southerly direction, and then yeah, it's actually a very cool feature, because then you can set the maximum slope in both of those directions, and you can then decide whether or not you want to exclude any tables that is outside of that range, or you can include civil works. So then RatedPower will include cut and fill in those areas to make sure that you are within the limits. And also, additionally to that, you can even go as far as to say that do civil works, but up to a certain point. So that you don't overextend your budget just on civils.
Exactly. No, that's quite.
You've got sufficient land. You know, if you're constrained on the amount of available land, and you need to hit a certain megawatt peaks, then obviously you will have to look at doing more civils.
Well, thank you so much. I think we have reached the time limit, if I'm not mistaken.
Yes.
I just see some other few questions regarding the recording of this webinar. If you're gonna send them the link, so we will send you the recording. And again, we didn't have much time to finish with all the questions, but we will get back to you by email with those answers. Yasmine, do you want to add anything else? Or?
No, thank you, Altair, for that. That's exactly it. So I would just like to thank Johann, yourself, as well as the attendees and the participants for the webinar, for sharing their insights, and for Johann for sharing your story, as well as very valuable insight and experience on your project. And as Altair mentioned, we will be getting back to you again with the webinar link and the questions that we didn't cover during today's session. Thank you so much.
Awesome.
Thank you, guys.
Thanks a lot, everyone. Thanks, Altair.
Thank you, Johann. Thank you, Altair. Thanks, everyone.
Thank you. Bye-bye.
Bye.